Alrighty, friends, let's make a review here, Mrs. Key. Ooh, a polar curve. That looks beautiful. So the graph of the polar curve, let's change this size. R equals 1 minus 2 cosine theta is shown in the graph above. Shh, it's to the right. Let S be the shaded region, so that little bitty region, in the third quadrant bounded by the curve and the x-axis. Write an integral expression for the area of S. So a big key here is that you need to know how to find area in polar land. So what that means is you need to remember that it's the integral from a to b of 1/2 r squared d theta. Comes from circles. If you have a sector, the angle here, is theta over the total radians in a circle, and then pi r squared. The pi's cancel out. You have 1/2 r squared, and then the d theta you think of as little chunks. And then we have, okay, so we got to talk about S here. So we need, let's see, so this is not a calculator question, so I have to think about this. So when I plug in, I'm going 0 to pi. So r of 0, that's 1 minus 2 times the cosine of 0. Cosine of 0 is 1, is -1. So that's right here. And then I need to know when we hit here, so that's when r is 0. So r equals 0. That's 1 minus 2 cosine theta. And that happens, add the 2 cosine theta, divide by 2. Cosine theta is 1/2 at pi over 3. So I'm going to be going 0 to pi over 3. So that means the area is from 0 to pi over 3, 1/2 r squared d theta. It doesn't ask me to calculate it, so that's all I need to do for that. That is it. All right, now, I see x and y. I always forget what this looks like. I don't know why. I just don't have it in my brain, I guess. I have theta here, x is here, y is here, r is here. X is along the horizontal because that's where x lives. Y is along the vertical because that's where y lives. So if I think of right triangle trig stuff, the cosine of theta is x over r, and the sine of theta is y over r. So we want dx d theta. So let's write an equation involving x and theta. So x is r cosine theta. R is 1 minus 2 cosine theta. And then r cosine theta, so r and then cosine theta. So that means dx d theta is just take a derivative. You could distribute this, or you could do product rule. I'm just going to do product rule. 1 goes away, and then the derivative of -2 cosine theta is 2 sine theta times cosine theta. And then you got to add 1 minus 2 cosine theta times the derivative of cosine theta, which is negative sine theta. And I did it. And then we've got to do the y stuff. So we know that we have this. So y is r. There are other ways to do this. This is just what makes sense in my brain, so it's how I'm doing it. But if you come up with a different way and want to talk to me about it, by all means. So that means dy d theta is 1 minus 2 cosine theta is still 2 sine theta, minus 1 minus 2 cosine theta, and then derivative of sine is the cosine. So that meets our needs for figuring out dx d theta and dy d theta. So now we just need to do part C. So for part C, it says, write an equation in terms of x and y for the line tangent to the graph of the polar curve where theta is pi over 2. So for a tangent line, I need a point and a slope. So x, as we already said, is r cosine theta. So x at theta equals pi over 2. Well, r at pi over 2 that's cosine of pi over 2, which is 0. So that's 1 times cosine of pi over 2, which is 0, so that's 0. And then y is r sine theta. And y, when theta equals pi over 2, is going to be 1 times 1, which is 1. So that's my point. I need a slope. So I need to find dy dx, but I could think of that as dy d theta over dx d theta, right? Just like dy dt over dx dt with parametric stuff. So dy d theta we found already. That's over here. So that's going to be dy d theta is 2 sine, so that's the number 2, minus 0, over, that has cosine in it, and then that has negative 1 in it. So negative 1. So it's 0 minus 1. So that slope is negative 2. So that means the tangent line is y equals the y value, which you don't need to write, minus the slope times x minus the x value, which again, you don't need to write the 0. But I wanted to kind of articulate that. So it's how we can connect polar stuff with the tangent line stuff we had before. And they kind of built this nicely, where in B I had to find those derivatives, and then C I used those derivatives to find the slope. All right, another series one. Okay, we can do this. Let's zoom in again. So that looks a little scary. You got cosine x minus 1 over x squared, then this negative 1/2. And g is the integral of that, plus 1, okay? That sounds a little scary, but let's read what we have to do. Write the first 3 non-zero terms in general term for the Taylor series for cosine. Oh, at 0. So cosine is an even function. So if you need to build it, you say, okay, I got cosine, then negative sine, and then negative cosine, and then sine, and then back to cosine. When I plug in 0, it's 1, 0, negative 1, 0, 1. So it's going to be cosine x is 1 minus x squared over 2 factorial, because it's 1 f double prime times x squared over 2 factorial. Triple prime goes away. Quadruple prime, fourth derivative, is positive x to the 4th over 4 factorial. Those are the first 3. And then the nth term is going to be x to the 2n, because we have even powers, over 2n factorial, because we have evens. So if it's odd, like 2n plus 1 or minus 1 would work. Use this series to write the first 3 non-zero term in the Taylor series for f about 0. Okay, so that means f is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 2n over 2n factorial plus some source. Oh, I just realized I missed something. That was a good catch. Glad I did this. I need the alternator, so I need negative 1 to the n. So I need negative 1 to the n. Because negative 1 to the 0 is positive, negative 1 to the 1 is negative, negative 1 to the 2 is positive, etc. And then we have to subtract 1 and then divide by x squared. So that sounds scary. But let's just follow our nose and figure it out. So we've got the 1's will cancel out. That 1 and that 1 will go away. So we're going to have, I'll write this out for you in case you need it, x squared over 2 factorial, negative x squared, plus x to the 4th over 4 factorial. I'll write the next term because I think I might need it. X to the 6th over 6 factorial. Minus dot dot dot. I'm not going to write the general term for this part. Over x squared. So divide each piece by x squared. So that's going to be negative 1 over 2 factorial plus x squared over 4 factorial minus x to the 4th over 6 factorial plus, okay, so it's going to be negative 1 to the n plus 1, x to the 2n, over, so it'd be 2n plus 2. Because it's evens, but I got to go a little farther, because I got to start later. So where I have a 2, I then have a 4, then I have a 6. So 2n plus 2 will work for that. And so I did that part. Use the Taylor series to determine whether f has a relative max, min, or neither at 0. Okay. So for part B, that's f. So f prime equals 2x over 4 factorial minus 4x cubed over 6 factorial. I think this is how you guys would think of it, and then I'll talk about another way. Plus and so on. Yeah, so I'm going to go this way, actually. So then I'm going to also look at f double prime. F double prime is 2 over 4 factorial minus 12x squared over 6 factorial plus and so on. So here's my argument. F prime of 0 equals 0. F double prime of 0 equals a positive, so 2 over 4 factorial. So we have a min. So what you have to write down is basically that. So since we have the first derivative is 0, second derivative is positive, that means we're concave up. And so we have a min, because the curve is going to look like this. So it's a second derivative test. You could have also looked at the coefficients, where you know, like, the first derivative coefficient is 0, and then the second derivative coefficient is positive. So you have that piece there. I found it easier to think about it kind of the way I did, but you could also think about it just based on the f of 0, f prime of 0, f double prime of 0, etc. All right, what else we need? Part C, 5th degree Taylor polynomial for g. So g is the integral of f plus 1. So for part C, we need to integrate f. So we know f is this one. So g is going to be 1 minus x over 2 factorial plus x cubed over 3, sorry, try again. Over 3 times 4 factorial, there we go. And then minus x to the 5th over 5 times 6 factorial. And do I need... That's it. So this is actually an approximate because it's the 5th degree polynomial. So all I did was integrate term by term the green right there. And then the last part says, Taylor series evaluated at x equals 1 is an alternating series with individual terms that decrease in absolute value to 0. Okay. Use the 3rd degree Taylor polynomial for g about 0 to estimate the value of g of 1. Well, okay, so they said, that sounds super confusing, but they said we have an alternating series. So they said, okay, approximate g of 1. So 1 minus a half plus 1 over 3 times 4 factorial, whatever that is. That's what g of 1 approximately is. Same why this estimate differs by less than 1 over 6 factorial. Differs from g of 1 by the x to the 5th coefficient. And that's because of the I'm going to get rid of this part, the alternating series error bound by the x to the 5th coefficient. So, since 1 over 5 times 6 factorial is less than 1 over 6 factorial, you would say the error is less than 1 over 6 factorial, which is what they're looking at. You probably should put the argument, I said it out loud, I didn't write it down because I'm kind of running out of room because my work's getting all over the place. You probably should put the argument in there that because this is an alternating series and the error for the alternating series comes from the first term you don't pay attention to, that's why I pay attention to 1 over 5 times 6 factorial. All right, so I hope I explained these okay to you. And good luck on your quiz, my friends.